Let's review right bundle branch block on the 12-lead EKG. As you recall from anatomy, the SA node communicates with the AV node. As the electrical impulse and message travels down the right and left bundle branch, there is a block of this message. This is called the right bundle branch block. As the electrical message travels down the unobstructed left main and the left bundle, this electrical message transmits across to the right ventricular wall and the rest of the myocardium. However, this causes a time delay. What does this look like on the EKG? Well, we can look at lead 1 and lead V1 for the answer. Remember, the total QRS complex is prolonged. The terminal S wave in lead 1, which is here, and an RSR complex in lead V1 is demonstrated here. Many providers say this looks like, quote, rabbit ears. However, the correct term is RSR prime waveform. To review, a right bundle branch block on a 12-lead EKG, it's demonstrated by a total QRS complex prolonged in lead 1 with an RSR prime complex noted in V1. Next, left bundle branch block. For the left bundle branch block, we see the blockage superior on the left bundle. This means the right bundle is responsible for transmitting the electrical message to depolarize the rest of the left ventricle. Now, what does this look like? Well, we look in lead 1. We look in AVL and V5 and V6. Here there is a wide QRS complex. There is also ST segment elevations in all 4 leads. The T wave is inverted, particularly in leads 1, AVL, V5, and V6. To review, the left bundle branch block does not demonstrate any changes in V1. In fact, V1 has a normal complex with an inverted Q wave and an upright T. Lead 1, AVL, V5, and V6 have a wide QRS complex with ST segment depression and inverted T waves.